Climate change factors. Earth's climate is affected by Earth's orbit around Sun, changes in Earth's atmosphere, fluctuations in ocean currents, positions of the continents, volcanism, variation in Sun's energy output, and impact events. Temperature. Earth's current temperature is primarily controlled by variations in Earth's orbit around the Sun. For the past 1 million years, Earth has experienced warm/cold cycles averaging every 100,000 years. These are called Milankovitch cycles, caused by variations in the shape of Earth's orbit, circular versus elliptical. For the period 1 million years ago to 2.8 million years ago, the Milankovitch cycles averaged 41,000 years, caused by variations in tilt of Earth's axis of rotation. Earth is currently in a geologic ice age, which began 33 million years ago with the formation of the Antarctic ice cap. This event was precipitated by plate tectonic changes, specifically the opening of the Drake Passage and Tasmanian Seaway, which allowed for the creation of the Antarctic circumpolar current. This allowed the creation of the Antarctic ice cap. The ice age intensified 2.8 million years ago with the formation of the Greenland ice cap. This event was precipitated by plate tectonics, specifically the closing of the Isthmus of Panama, and the creation of the Gulf Stream. Ice ages are characterized by many long cycles of extensive cooling, with multiple advance and retreat of glaciers, glaciations, interspaced with short periods of warmer temperatures, interglacials. Earth's average temperature has fluctuated about plus or minus 3 degrees Fahrenheit at various times over the past 4,500 years. Fluctuation periods variously span 400 to 1,000 years, influenced by volcanic eruptions. Earth's current temperature is the lowest it's been in the past 278 million years. At that time, Earth was again experiencing an ice age. Temperature at that point in time was lower than present, from 278 million years ago to 355 million years ago. Earth's average temperature fell below present about 2.8 million years ago, and stayed that way until the present interglacial period, which started Earth's current warming trend 21,000 years ago, and peaked 11,000 years ago. During each of the 4 previous interglacial periods, Earth's temperature was higher than present, by 2 to 5 degrees Fahrenheit. During each of the 4 previous glaciation periods, Earth's temperature was 8 degrees Fahrenheit colder than present. Atmospheric carbon dioxide. Earth's atmospheric carbon dioxide currently is at 410 parts per million. Was about 7,500 parts per million 550 million years ago. Was about 1,000 parts per million 66 million years ago. Was about 500 parts per million 5.5 million years ago. Was about 375 parts per million 1 million years ago. Was about 180 parts per million 20,000 years ago. During most of the past 1 million years, atmospheric carbon dioxide has fluctuated between 180 parts per million and 280 parts per million, in general sync with changes in Earth's temperature. Warm temperatures can raise atmospheric carbon dioxide, cold temperatures can lower atmospheric carbon dioxide, high atmospheric carbon dioxide can raise temperature, low atmospheric carbon dioxide can lower temperature. Atmospheric carbon dioxide. Atmospheric carbon dioxide is driven by Earth's complex carbon cycle. Atmospheric carbon dioxide has been gradually going down because of an imbalance in Earth's carbon cycle going back billions of years. Sea level. Sea level has varied widely over the past 550 million years. Current sea level is about 460 feet higher than 20,000 years ago, during last glacial maximum. Was higher than present during 3 out of 4 last interglacial periods. Was 26 feet higher during last interglacial. Was about 1,300 feet higher 465 million years ago. Was about 1,083 feet higher 430 million years ago at the ending of a 30 million years long ice age. Was at present level 232 million years ago. Was about 885 feet higher 75 million years ago. Was about 1,180 feet higher 52 million years ago. Sea level is influenced by air temperature, evaporation, water temperature, expansion, ice age glaciations, forming and melting, and plate tectonics, arrangement of continents. The Greenland ice sheet formed 2.8 million years ago. Sea level would rise about 58 feet if the Greenland ice sheet melted completely. There is evidence that this has happened at least once within the past 1 million years. The current Antarctic ice sheet formed 33 million years ago. Sea level would rise about 260 feet if the Antarctic ice sheet melted completely. Hard facts. Earth started to enter its next natural cooling cycle about 6,000 years ago, due to forcing by Milankovitch cycle, but anthropogenic atmospheric carbon dioxide, already in the atmosphere, offset that trend, prolonging the current interglacial. Humans have consumed about 30% of all recoverable fossil fuels so far. If burning of all fossil fuels stopped immediately, Earth would continue to warm, regardless, for the next 200 to 1,000 years. Anthropogenic atmospheric carbon dioxide already in the atmosphere will likely postpone the next onset of glaciation by another 20,000 to 50,000 years. If all remaining recoverable fossil fuels were burned immediately, the next onset of glaciation would be postponed by another 500,000 years. But eventually, Earth will again enter a long period of glaciation, with devastating consequences for humanity. Just something to consider.